Welcome everyone to today's exploration of how artificial intelligence is fundamentally reshaping the field of architecture. We're witnessing nothing short of a revolution in how architects conceptualize, design, validate, and communicate complex systems. What makes this transformation particularly fascinating is that it requires not just technical adaptation, but psychological readiness to embrace entirely new workflows that combine human expertise with AI capabilities in ways that were science fiction just a few years ago. For architects willing to evolve their practice, the opportunities are extraordinary. Let's dive into how this is happening and what it means for the profession. Part 1. How AI is revolutionizing architecture. Let's begin with diagram generation, perhaps the most visible way AI is changing architectural practice. Traditionally, creating architecture diagrams across different levels of abstraction was time-consuming and often limiting. Architects would typically explore only a handful of options due to time constraints. Today, AI tools like Miro AI Assistant, Midjourney, Excalidraw with GPT Vision integration, Lucid Chart AI Assist, Microsoft Copilot for Visio, and Enterprise Architect's AI Assistant are transforming this process entirely. These tools can rapidly generate multiple candidate diagrams based on requirements or system descriptions. Architects then review, combine, and refine these generations, applying their domain knowledge and understanding of stakeholder context. The AI can suggest design patterns, identify inconsistencies, or generate alternative views tailored for different stakeholders. Some forward-thinking architecture teams are even using AI as a participant in design workshops, rapidly visualizing ideas as they emerge in discussions. This enables real-time exploration of concepts that previously would have required days of preparation. Requirements analysis is another area experiencing profound change. Traditional requirements validation was painstaking work, requiring architects to manually review hundreds or thousands of requirements for quality issues. Now, AI tools can identify requirement gaps, ambiguities, and inconsistencies across large requirement sets, helping architects focus on quality issues rather than hunting for them. Solutions like JAMA connected with AI analysis, IBM Watson for requirements, and specialized requirements GPT can transform vague stakeholder statements into precise, testable requirements. Let me share a real-world example. A financial services organization reduced requirements validation time by 70% using AI to scan over 3,000 requirements for a core banking system replacement. The AI flagged 15% of requirements as potentially problematic, helping architects focus their attention where it mattered most and significantly accelerating the project timeline. These AI systems scan requirements for words with multiple interpretations, vague quantifiers, or undefined terms that could lead to misunderstandings. They identify missing requirements by analyzing patterns in similar projects and reference architectures. They detect potential conflicts across different domains or stakeholder groups, and evaluate requirements against known technology constraints to ensure feasibility. When it comes to design and exploration, AI is enabling architects to work in fundamentally different ways. Instead of painstakingly creating a single design option, architects can now rapidly generate and evaluate multiple alternatives in parallel, exploring wider solution spaces early in projects. The shift from creating content from scratch to selecting and refining AI-generated content represents a profound change in how architectural work happens. It's moving from a waterfall model of architectural definition to something much more agile and comprehensive. Perhaps most importantly, AI is transforming stakeholder communication, often the make or break factor in architectural success. AI excels at translating the same architectural concepts for different audiences, ensuring each stakeholder group receives information in the format and detail level most useful to them. For executives, AI can generate strategic summaries focused on business alignment. For implementation teams, it can produce technical details necessary for development. For operations, it highlights maintenance implications and operational concerns. Beyond basic translation, AI can detect concern or resistance in stakeholder comments during architecture reviews, helping architects address issues before they become obstacles. It identifies when stakeholder feedback conflicts with previously stated requirements, highlighting potential misalignments. It can even predict likely questions or concerns before they arise, allowing architects to prepare comprehensive responses. Some organizations are using AI to analyze past interactions and build profiles of stakeholder preferences, concerns, and communication styles. This enables more effective presentations tailored to specific audience segments, increasing engagement and understanding. Part 2. The importance of human oversight. Despite AI's impressive capabilities, human architects remain absolutely essential for providing critical oversight and judgment. The most successful architecture practices establish clear touch points where human expertise is deliberately applied in what we call a human-in-the-loop approach. This ensures AI serves as a powerful tool rather than an unquestioned authority. Humans must define the business context, constraints, and unique factors that AI cannot infer from general knowledge. They integrate insights across domains in ways that domain-specific AI may struggle with. Human architects must evaluate AI-generated architectures for alignment with organizational values, ethics, and cultural factors. They remain essential for translating between stakeholder concerns and technical solutions, providing the empathy and relationship management that AI cannot replicate. Best practices include specific steps where humans verify AI-generated content against domain knowledge and organizational context. Some teams clearly mark which aspects of architectural artifacts were AI-generated versus human-refined to enhance trust and accountability. Others deliberately identify where AI recommendations fall short to create opportunities for improving future AI performance. Part 3. Potential pitfalls and how to avoid them. The integration of AI into architecture practice isn't without challenges. On a professional identity level, AI challenges architects who build their identity around being the most knowledgeable person in the room. It provides rapid access to patterns and solutions that may exceed an individual's experience. Architects must develop a healthy verification relationship with AI outputs, neither blindly accepting nor reflexively rejecting them. Successful architects reframe AI as extending their capabilities rather than replacing their value in the organization. There are also technical limitations to be aware of. AI may generate plausible-sounding but incorrect or non-existent architectural patterns, especially at the cutting edge of technology. AI training cutoff dates mean awareness of recent technologies, standards, or best practices may be limited or outdated. AI lacks awareness of organization-specific constraints, politics, or history unless explicitly provided in the prompt. It may over-standardize architecture approaches, missing opportunities for innovative differentiation that could provide a competitive advantage. The biggest risks come when architects accept AI recommendations without verification, potentially introducing errors or inappropriate solutions. As AI handles more tasks, it could reduce the architect's ability to function independently. Some architects might attribute architecture decisions to AI rather than taking professional ownership, undermining accountability. To mitigate these risks, compare AI outputs against multiple authoritative sources to confirm accuracy. Have subject matter experts review AI-generated content to identify potential issues. Test architectural concepts in low-risk environments before wider application to ensure reliability. And compare AI recommendations against historical outcomes in similar contexts to assess likely success. Conclusion: the integration of AI into architecture practice represents a fundamental shift in how complex systems are designed, documented, and communicated. Successful architects will develop a symbiotic relationship with AI tools that enhances human creativity, insight, and judgment while automating routine aspects of architectural work. The architect of the future will be distinguished not by their ability to manually create every aspect of an architecture but by their skill in orchestrating human and artificial intelligence into a cohesive whole that delivers superior outcomes. For those willing to embrace this transformation, the potential is extraordinary: more comprehensive explorations, faster delivery, better stakeholder engagement, and ultimately, more successful architectures that deliver real business value. Thank you for joining this exploration of how AI is transforming architecture. The journey has just begun, and the possibilities ahead are truly exciting.